or should I just go for it?
I'm going to do a quick introduction.
Okay.
Good morning, everyone. Thank you for taking the time out of your schedule to join Vandis and SentinelOne for this webinar entitled Bringing Endpoint Detection and Response into the Modern Age. Before we get started, I would like to invite you to take a moment after the webinar concludes to check out the events page of our website at vandis.com/events. This page details all of our upcoming in-person events and webinars and gives you the opportunity to register for anything that may be of interest to you. Today's webinar will be hosted by Grant Marshall, Lucas Chumley, and Jim Vanderwright, all Senior Solutions Engineers from SentinelOne. Before I turn it over to them, I would like to request that you please mute the microphone on your computer or phone if you are in a noisy environment to eliminate any background noise. If you have a question, please feel free to ask it at any time during the webinar or type it into the message window. We will also leave a few minutes at the end of the session for Q&A. With that being said, we are going to go ahead and get started, and I will now turn over the webinar to Grant at SentinelOne.
Hey, everybody, this is Grant Marshall. Thanks for your time today. Really appreciate it. I know everybody's busy, but we hope to make the next little while here something that's fruitful for you. To give you a little bit of background about how SentinelOne views the detect and response space with some of the capabilities within our product. Today, we're going to cover a couple of points, and then we're going to get into 3 demos towards the latter part of this webinar. I'm going to start off a little bit today with just a Cliff Notes history of where we've been in the last 30 years or so. Some of the security operations challenges that we see today in the market, as well as the market confusion that just seems to abound everywhere, and our approach to converging and automating in a better way to help businesses. And then we'll get into those demos. The demos, just real quick, we are going to show a demo of our EDR capabilities and show you how it's easier to find interesting artifacts within your environment. We're also going to show a protection demo where we stop some ransomware. And then the third demo, we're going to show essentially the same item, the same thing as the second demo, but we're going to let the ransomware run, and we're going to show how we can recover very quickly from an attack. So with that being said, let's go ahead and get started. Advance the slide here. So some of you may know Dave in your environment. So it doesn't matter what we do in a lot of ways from a control perspective. We always have that human element that can find a way around the best intended protections. But we look at the endpoint as essentially a sponge for malware and fileless attacks. And why is that? It's because these are the computer systems that are most mobile. They tend to have the most applications. They are hardest to manage, and they're just out and everywhere. And it's difficult to train people to the point where they will not do those dumb things. So we're up against a lot here in the industry. So over the years, we have invented different ways to protect against the offensive measures that attackers have had against us. And the reason that this is a coil is because it just seems to go round and round. If you look at the history of all of it from time starting at the top on down, the adversaries have invented all sorts of novel ways to get at us. And as a response, we have invented all sorts of defense mechanisms. And the hard thing here is that you can't forget about the past, because everything all the way back to the first attacks still could be worries today in your environment. So you have to have this additive protection all the time to defend against what may be coming next. So let's move quickly through this Cliff Notes history. So back in '87, essentially McAfee was born. One of the first, if not the first one, along with companies like Trend. we saw in the 90s how the legacy, what we call now the legacy AV industry, really began to build up. And essentially, these products were all very similar. They were the same stuff, different wrapping paper around it. And these companies began to differentiate by building out what we call security suites, adding things like firewall control mechanisms, URL filtering mechanisms, data loss prevention, maybe enhancing what some protections against what some of the attacks were at the time. And then could somebody please mute? Thank you very much. So then as we moved into the 2000s, we began to see other types of products come about. Bit9 is an example. So app whitelisting. So instead of trying to figure out what's bad, define everything that's good and just consider everything else bad. Sounds like a good idea, but has extreme scalability problems, especially in dynamic environments, which is pretty much everybody's environment. And then we began seeing, throughout that time period, Snort, FortiGate, Palo Alto, Checkpoint is not on the list here. Let's see if we can not only block and reduce the attack surface, but maybe let's try to catch this in motion across the network. And it's a good idea. It still has its place in our enterprises today, but that does become increasingly difficult because of the sheer volume of network communications, as well as the increased use of TLS and SSL more in the past in these environments, and trying to figure out what is on the wire because it's encrypted. So again, moving through time, we're now in the early 2010-ish, time period. FireEye comes out. This is more dynamic analysis, sandboxing. Let it run, see what it does. If it does something bad, then let's go ahead and stop it. Great idea, but it had a somewhat of a shorter shelf life, as we can see, because the attackers figured out how to do detection. In other words, they began engineering their malware in such a way that it could detect if it was in a sandbox and then make itself more benign so that it wouldn't be caught. Then we moved into what we call the first wave of EDR, Endpoint Detect and Respond. And so the idea here with some of the vendors was, let's just go ahead and give you all of the evidence, and then you can go ahead and piece it together and figure out if it's bad or not. Okay, these EDR players in the market are very data intensive, data-centric types of solutions. But then on the opposite end of the spectrum, we saw other vendors coming out with, well, we're going to use static AI to prevent everything, and that's all you need to stop attacks. But for anybody that's ever looked closely at those solutions that are very much focused on just prevention, they kind of leave out a lot of the dynamic attacks like fileless attacks and exploits, bad macros, scripts, that type of stuff that are being used against you. So, hang on, sorry, wrong direction. So then we saw more flight data recorders come onto the marketplace. SentinelOne, we've been around for 6+ years now. We started as more of a convergence of the endpoint protection and the endpoint detect and respond, more of like a convergence play, but we'll get more into that later. So a lot of new vendors compacted very closely, being introduced into the market just in the last, let's say, call it 4 to 7 or 8 years, trying to solve the problem of this attack cadence, where the attack cadence, what I mean by that is the attacks are just off the charts, whether it's file-based malware or just the increased use of non-file-based attacks. So it's this amalgam of lots of different types of attacks just hitting you right and left all the time. So if we look at some industry observations, this is a graph from the Verizon Data Breach Investigative Report. This is from last year, but they have a very similar type of observation in their very recent report. And the way you look at this is that the compromises come very quickly. In other words, a compromise can occur in just a few seconds, minutes, and the exfiltration, which is the lower graph, begins immediately, typically. This is Verizon, very well respected industry organization. Love their reports. If you haven't read them, do encourage you to do that. So what Verizon goes on to say is that, and this is the overlaid more purple graph, is that detection and containment tends to be slow. So while the attacker is exfiltrating immediately, the way to look at this is that it takes a longer time typically to detect those attacks in the environment, by which time the attacker has essentially moved on and is just on to something else in your environment, or has done the hit and run and you're the victim. So let's look at a couple of business constraints. So other business constraints is that we have a ton of tools these days, a lot of complex tools to master, to expect the security staff to operate, a lot of panes of glass to deal with, information coming from all sorts of locations. And we all know that there's shortage of domain experts out there. There's a lot expected of people, and there's just aren't enough folks out there to fulfill these roles. And really, the data overload is huge. If you ask anybody in the space, and I'm sure you all know, those of you on the call, that it's just there's not enough time to deal with everything that's coming at you. So essentially, in a nutshell, we don't have enough people, and we don't have enough time to deal with the threats. So today's SOC analyst is essentially is on fire. They're keeping an eye on everything that's going on when they can, but Rome is burning around them is kind of the idea in a lot of cases. So the market doesn't help. There are a lot of competitors in the space, a lot of people doing things, making claims, a lot of people using terminology and language, and it all sounds very much the same. So when we are talking to customers, we really want to make sure that we understand what they mean by some of these words, because we want to make sure that we're on the same page. And it's just important to do, okay? To make sure that we're trying to solve the same problem in approximately or identically the same way. So let's talk briefly about the last little while and what it has to do with this last 5 to 7 years or so. We have these pure prevention plays, or the endpoint prevention. And then we have the pure detect and respond plays. So on the left side, we have the promise of it is that it's going to be an AV replacement, and you're not going to have signatures. It's going to really save you a lot of time, was the idea. But in reality, the pure prevention plays have proven to be less flexible and just less effective, as I mentioned before, because they're not really taking into account at all or very well some of these more dynamic attacks. So you see the endpoint protection vendors sort of moving to the right and adding some EDR capabilities. And then on the other side of the spectrum, again, this is the promises, is here's all of the evidence you're going to ever need. And the reality is from that is you get crushed by your data. You get too many alerts. It's very manual and labor intensive. And again, we've established, and you all already know, there just aren't enough folks to deal with this. So you see EDR vendors who kind of started in that world sort of moving to the left is the idea. So the market direction, and I've been in the endpoint space for 5 or 6 years now, and you've seen this kind of full motion from the left, swooping to the right, and then it's back again towards the center. So what's the way forward? The way forward really is to converge these mechanisms and automate as much as possible. This solves a couple of problems for us. It's going to take care of the file-based attacks without using signatures and be able to predict and prevent them whenever possible. it's also going to take care of these fileless attacks. And as you begin to automate more, you can reduce your dwell time at which an attacker is on the endpoint and react either manually or hopefully automatically so that you can stop that. So I'm going to just dig into just what we're doing at SentinelOne here, and then I'm going to hand it over to Lucas, who's going to get into that first demo. So stick around. I want to kind of give you this background as a kind of like a very brief primer as to what we're doing. So the underlying technology at SentinelOne is a couple of different things. Whenever possible, we want to prevent. So we have a couple of different mechanisms that I'm going to discuss here. The first one is this prevention mechanism. And what we're doing is before a portable executable or a PDF or an Office doc, before it ever runs in memory, we're going to analyze it and we're going to figure out if it looks odd in some way. And if it is, if it's different from what we know to be good, we're going to go ahead and sit that off to the side, also known as quarantining it. The next thing that happens is if code begins to run, maybe it has passed that first test and it begins to run. This is where our active EDR, which is it's an autonomous, automated threat hunting mechanism that includes the detect and the respond within the agent. And this is taking care of these fileless attacks. It's looking for odd lateral movement that may be occurring. It's looking for things like, I opened up Word and it spawned PowerShell and reached out to the internet to fetch something. That's not correct in most cases. So we're going to go ahead and do that detection as it's running. And what we're doing here, and this is really part of our crown jewels, is we track everything that happens in the OS as a set of stories. We look at what the story does from its inception to its termination, whether that's 1 second or a month or more. And we essentially are constantly weighing it to figure out if it has, as I say, quote, gone evil in some way. And if it has, then what we can do is we can have a protective response. So that's the next step, is the responding, okay? And we have all sorts of responses in our product. I'll just hit them briefly here. It's the basic stuff like killing and quarantining, okay? Table stakes, everybody does that. But what we're doing a bit differently here is that we can automatically or manually at the administrator's, whatever the administrator's needs are, clean up from an attack. In other words, reverse the unwanted changes. We can even roll back a system, and Lucas is going to show you that. We can do things like disconnect it from the network. You can do a remote shell into it, these types of things. And we make this automatic and one-click simple. And all three of these major areas here, this all takes place in seconds. We're not cloud reliant to do any of this stuff. We don't have to upload a bunch of data to have humans look at it. We don't have to have cloud analytics to deal with this. We're doing this on the agent, and that is a huge differentiator for us. But nobody will ever catch everything. And so we have another part of our product, which is called Active EDR Advanced, also known as Deep Visibility. And this is for threat hunting. And in the first demo here, Lucas is going to show you some interactions among systems where the threat hunter, and this is Lucas in this case, is looking at artifacts and tracking some behaviors that are seemingly innocuous, but all put together are, not good behavior in the grand scheme. And this is how the attackers who may already have credentials in your environment may be doing things like what we call living off the land. And it's a way to detect that. So what we do is we store all of this, what we call benign data, for 90 days by default. You can go back to a 90-day history. And very soon here, we'll be offering a full year of historical data searching at your option. So with that, what I'm going to do is I'm going to turn it over to Lucas. And Lucas, take it away.
Sure thing. Good morning, everyone. Going Great, if you wouldn't mind, go ahead and making me presenter there.
Okay, you should have it now.
I do. Brilliant. Okay. So good morning again, everyone. As Grant said, I'm going to run through a few different things. We're going to start with that threat hunting piece that he mentioned there at the end. And we want to go through and explain, the benefits of threat hunting and what separates threat hunting from the detection and automated responses that he also spoke about. So these are just a few of the traits that. Oh, pardon?
We see a white screen there. I'm not sure if it's showing anything. There we go.
How about now?
No. I could see it there yeah, I can see it now.
Okay. All right.
Looks like it maybe is not going into presenter mode correctly.
Yeah, present mode seems to be.
That's fine.
But yeah, that's all right. So we have the, some of these traits, and we'll be building this out as I go through each of these. And this first section here is really about adding the context to the artifacts that you're hunting. A lot of these solutions with EDR, as was mentioned, they're so data centric and there's so much data coming through that it's hard to really tell which piece of data goes where. If you're doing these flight recorder motions and you have all of these processes that are spawning, and they spawn children processes and they touch these files and they manipulate the registry this way, it can be a real effort to go through and try to, pin the tail on the parent PID and figure out exactly what chain of events happened due to what process, and even what started that parent process to begin with, if it's not normal. So we provide all of this context, and it's a really simple one-click context solution. So the benefit to both of these things are less fatigue all around. Not as many alerts going off because we know that one alert, we know the full story of that alert, and then less fatigue for any analysts that's working in the system because you don't have to go through thousands and thousands of events trying to figure out what we did. And we call the feature True Context ID. And you can see kind of the difference between our True Context ID and all of the other ways of threading behaviors together. You start out with IOCs, and it's just these seemingly random words of descriptors of a bad action that's happening. And you have the IOAs and TTPs, which are slowly but surely, they're more organized. They give you just a little bit more context of what's going on. By the time you get to TTP, you can actually see that this is a description of someone. Our True Context ID is a lot more like the entire DNA strand. We're no longer just trying to describe these traits. We're putting the entire story together of the traits that made up this bad action. When you're going through and doing threat hunting, then it's a mindset, and the mindset is always, we're breached. It's not relying on alerts to go off. It's not relying on to be told that something's bad. It's actually a very taxing mindset to have. It's not necessarily negative, but you can't just look at a dashboard and say, there's no alerts, we're good. It's a constant thinking of, we are breached. So where do I find this breach? How do we contain it? And how do we remediate it? So when you take this mindset and apply it to everything that you're doing, then you have to work from, an evolving hypothesis. And this hypothesis comes from, reading up on the latest breaches and staying informed, and it comes from your own threat intel. It comes from blue and red team exercises. An evolving hypothesis is simply, of this stack of data, what is the kind of stuff that we're going to look for? And I have a kill cycle here. This is the Lockheed Martin kill chain, and just some examples. So we have the, for the weaponization era, we have Office macros and JavaScript inside of PDFs. And then for command and control, things like processes making calls out to the internet that shouldn't be doing that, or maybe processes that are doing beacons, you know, and it's on a set timer. You can see them reach out to certain URLs or web addresses. And for delivery, of course, we have email and drive-by downloads and external drives. So these are all things that that's going to be threat hunting should be keeping in mind. And these are all ways that you can go through stacks of data and kind of put them together. Then again, as we've mentioned, I put together that an Office document had a macro in it. Then what? I have to figure out where the Office document came from. I have to figure out, was it double-clicked? Did it automatically execute? You know, the delivery mechanism. There's, you know, did it come from the email or a USB drive? And this is typically a very manual process with most EDR solutions. But we're going to show exactly how all of this comes together relatively quickly. So the scenario that we're running through, very basic attack type. We have an RDP session going to a Windows machine, the Tyrannosaurus PC, and from there, that once the RDP session is connected, then using the remote control of the Tyrannosaurus PC, the attacker then runs psexec to Pterodactyl PC. I chose psexec because it is a sysinternals tool that's sanctioned by Microsoft. You're never going to find signature validation problems, and it's commonly used to actually do real IT work. So they use psexec to connect to the Pterodactyl PC, and then using that command prompt that they now have from psexec, they open a PowerShell and they tell PowerShell to make an archive of everything in the documents folder, and to zip all of that up and put it into a directory. And then once that directory has been created, and that zip file has been created, then they exfil that data to an FTP server. So using this simple walkthrough, this simple attack, and our attack hypothesis, then, you know, some of the things that you could query would be things like PowerShell having internet communications or single character process names. And the single character names are a big deal because no attacker wants to have to type long commands. So they have the tendency to rename these things. Same with the file names that they have. We could also check for you know, processes reaching out and using IP addresses instead of using domain names. So specific IPs not being attached to domains is usually a good one. And then there's some other examples mixed in here, things like, you know, a Mac process executing from a DMG container, meaning it was executed immediately and not properly, quote, installed in the Mac OS fashion. And then things like Chrome developer tools running, which is usually someone looking for API calls. So having said that, I'm going to show directly here our attack. So make sure we don't just see a white screen again. All right. So using some of these ideas from these queries, I could go through and start taking a look at all kinds of data. Now I have some of my queries saved here, and I'm going to simply look for those, you know, that single file name, single process, and it's going to check for the last 48 hours here. And we can see on Pterodactyl PC, there's 3 that have come through in the last 48 hours. We'll go ahead and we'll take a look at this one. Now, this is what I'm talking about with typical EDR solutions. I pulled together this full file name is just a single file, and it's either a PS1, a batch file, or a zip file. Well, I have a result, and here's our result. But this is all it's going to give me, and this is all that most EDR solutions are going to give you. We have the full file path, we have the process name that created this zip file, and we can see the file name, this z.zip. But that doesn't tell me what's happened. That doesn't tell me where this came from or anything like that. So our true context ID is right here, and I can simply select the true context ID and come down here, and we'll do a new query on it for the last 48 hours as well. And we'll let this run. And this is pulling together the entire story, everything that had to do with this file being created. So we can see once I search for that true context, I go from having one single hit for a basic query to having 35 different events that spans processes, files, network actions, and registry changes. So we now have this entire thread that's pulled together. Simply click this over here, and instead of looking at that table of data where we have to constantly go through and check, I'm just going to start with the oldest PID, and I just want to start from the very beginning of this attack and walk through. And so now it's putting the story together for me in a more relatable fashion. So I have this command line here, and I can see that it ran on the pterodactyl PC, which was the second PC in our attack, and it simply just opened. So the command line opened. And we have the console host here, which is going to open anytime command line does. And then we have our first PowerShell. If I click on the first PowerShell, then I can come down and see, first of all, I can see the command line that PowerShell was given when it opened. And it was to compress the archive path at the documents folder, and then put the zip file in the users folder. And I can come down here and take a look and see exactly what files were created, which ones were modified, any registry values that were modified, processes that were created, which is obviously just the PowerShell executable here, and then files and the file changes. So even though we have a lot of the built-in Windows PS1s that will happen when commandlets are used, these spawn naturally, it's part of how PowerShell works, we can see this last one, this file creation of z.zip. So we know that this PowerShell is this command and this file were all created from this command line. I can scroll up and click the next PowerShell that opened. And this PowerShell that opened attempted to use a download string from this address and get this PS1. The interesting thing about this is that I can see down here that there are no network connections, which means that this command likely failed. It failed to actually give the attacker what they were looking for. I have nothing here except the base Windows PS1 files from the PowerShell command being given, and there's no new file creations. So looking at the last PowerShell that opened, we can see that this command is nearly identical, except now it's using an IP address. So this IP address is probably the IP address that the domain was supposed to be pointing to when the attacker gave the command. And we can see down here that we have network actions. So this time it was successful. There were actually network connections made out. And we can see that it attempted to just execute this send.ps1 from this IP address, from this web server. I come down here and we can take a look and actually see that, yeah, outgoing, here we have the source and destination ports. So first it reached out to the web server that we see here, this 165, and here's our destination IP, and got that PS1. And then from that event, port 21 opened, connecting to a completely different IP address. So 65 is where the web server was, and 61 seems to be where an FTP server is. So knowing that all of this happened within one command line, 3 different PowerShells opened, it created a file and then started connecting out and got further commands from the outward web server to send over port 21. And we can see that that was established as the ports changed and the FTP server went into passive mode, and then proceeded to send this z.zip file. The coolest thing about being able to tell this story is it was one simple search that brought me here. All I did was simply search for single character file names and zip files. And then our true context ID put the entire rest of the story back together. So our true context ID looks a lot more like this. All of these events that take place, instead of them just being scattered around, are all threaded together in a single storyline, the single piece of DNA that says all of this attack is what happened regarding this PowerShell exploit and exfiltration. Okay, so that's hunting and true context and how we put all of that together. I'm going to move along, and this is going to be demo number 2, and this is going to show our prevention and the automated EDR for like Office documents and things like that. So let me just pull up our computer, our victim computer.
So while he's pulling that up, this is Grant again. Just as a point of reference, so we're pivoting to this second demo, and this second and third demo that we're about to show you are very much interrelated. The first one shows us outright preventing technically detecting and responding to in an automated way. And this gets back to, we don't have time to hunt for everything, even though we give that facility to you in the product. This is the product doing the hunting autonomously on the endpoint agent and having an immediate response to an attack. Go ahead.
Sure. Thanks for that. Okay. So we're going to pull up here. All right. So here I simply have my dashboard, and I have 0 unresolved threats in it. And we can see over here, I have a computer that's sitting here, and this is protected by the same installation. And I can go into Word and open a document. I'm going to open a document, a maliciously formed document, and we'll click here and have that open up. And we can see pretty quickly that we get the threat detected, and you can see over here that I have one suspicious detection. And as the user reads this malicious document to see what's going on, they just read it down. This document's actually opening up and doing everything that was described earlier, as far as it's reaching out to the internet, it's looking for, more commands, all kinds of things like that, and trying to get together some more information to go. So as this opens up there, we can take a look over here, and while we're looking at this, we can actually see over here that threat went full detected, it closed Word, and now I no longer have that malicious document on my desktop. So it completely remediated, and then when I come over here, I have the green check mark. So the green check mark's saying that this has been resolved. And it just did a simple quarantine. We can see here where it says actions killed and quarantined, and it was as simple as that. The file went from sitting on my hard drive not doing anything, and as soon as it started executing and reaching out, then it went ahead, and we saw mid-process where it was going and said that this is no good, and we cut it off. So that's it. It's just simple protection, and that's the automated EDR for when things are in protect mode. So this would be typical of your end users. Lastly, moving right along, going to show what happens when there is no protect mode, when we're in a mode of detection only. So if I come here and take a look, then these are the 2 different modes that we're in, detect and protect, and this endpoint here is actually doing detect only. All right, we'll go back to our dashboard. And in this particular user's world, they have an email here that is from Mozilla support, and they open this email, and then they open this document to talk more about this vulnerability and where it comes from and who it is. And we can see the same thing here, that we get this threat detected, and we now have one new suspicious detection here in our console. And then that suspicious detection immediately goes to an unresolved threat as the endpoint agent starts to realize what's happening here. So the user sees the threat detected, and they close Word in a hurry. They kind of close their email. Word opens back up as more stuff is happening, since this has already been set into motion and there's no protect actions going. And so we can see that it's opened up this privacy policies document, and we close that. And now you can start to really see what this malware is trying to do. And you can come through and see that all of my pictures, all of these delicious fruit photos are disappearing, and they're encrypting. So they're all becoming nothing. We have a decrypt info, URL here, pretty typical of this kind of thing. And once it gets done decrypting all of this user's files, then what we're going to see is the signature pop-up that says there's a timer, and here's the code that we need to give us, and here's our bit wallets to send the ransom. So this machine is useless. All of the documents that are on it have been encrypted. There's nothing I can do about this. And I want to stress that this is live malware, and I don't have any of the decryption keys or any of those mechanisms available to me. So I'm actually going to just kind of refresh and relog in here. It looks like my session's expired. All right, go back to R2. I have this here. So this is showing everything that's happened and where this came from. And once again, since this one isn't in any kind of protection mode, it just ran. We have the name of the document that kicked all of this off. We can see that no actions have been taken because it's in alert only mode. And we can start to come down here and take a look at the summary. And of course, we map everything to the MITRE ATT&CK framework. So we know that it was this execution, the document behaves abnormally, and PowerShell was doing post-exploitation actions. If I want to see what really happened, then I can take a look at our attack storyline, and this puts it all together for us. So I can see that Word opened, and when Word opened, PowerShell opened, and when PowerShell opened, it really started wreaking havoc on the machine. Everything from making my temp folder hidden, gave it a +H argument on the temp folder, to trying to delete all of the shadow copies and anything that might be used to resort back to a previous known good on this machine. We actually protect the shadow copies here, so we told the malware that all was well and that it successfully deleted the shadow copies. We can see this is where Word opened again. After the user had closed Word, this new document opened, and it went to this GPO update text file. So we have the entire storyline here. We know everything that went down, and that's really important. Because we have this attack storyline, we can actually reverse it. So if I was concerned that this attack might go elsewhere on my network, it might start spreading, I could click disconnect from network here, and that would shut off all agent communications between this agent and the network, except for communication back to the console, so I could continue my investigation. So I'm going to click roll back here. I just want it to reverse everything about this storyline. Click continue, and it's applied it. So we're going to start going through this storyline and restoring everything. And you can see instantly that my timer is gone, and surely all of my files come back. Because the rollback mechanism is the last line, the last point on this linear graphic here, when I take a new look, I can see that it actually applied every action up into this rollback point. And that's great, because not only have my files been restored completely without me having to pay a ransom or know the decryption, but now when I open mail and I take a look at this same message, we can see that this is no longer a clickable document. And that was a part of our remediate. We went all the way back and found where this document was and got rid of it. So this document can't be reopened, and we can't wind up in this cycle of infection. All right. So back to our slides.
So while he's bringing that up, I hope that the differences amongst these demos are understandable. Really, we have the threat hunting as well as the prevention and the recovery. So go ahead, Lucas.
Sure. So at the end of the second demo, that was simply the protection mechanism, this autonomous protection and response, faster detection, less dwell time. The malware that came from that same document had absolutely no time to execute before it was remediated and deleted. So we quickly quarantined it and stopped the malware and ransomware from actually infecting the machine. This last one that I showed you, we showed fast recovery. So it takes a lot less money to simply roll back these actions than it does to pay the ransom or have to spend hours restoring a machine and then hoping that anything that the user was working on is in some kind of a viable backup. So all of this runs from one agent. On any OS, I showed 3 predominantly Windows-based attacks here. Any OS, and we do both on-prem and cloud solutions, and we have a really great API that's really well documented. We've seen some really interesting integrations done using our API, and because of the simplicity of both the rollback mechanisms and the remediation actions mixed with the autonomous actions of the agent, then the software is really well designed for every one-man team up to a larger team. So any person and any response. And of course, I demonstrated both automated and manual responses today. All of that having been said, go ahead.
So kind of because we're probably up on the end of the webinar. This is kind of how this is how SentinelOne is contributing to the security operations team's success. Any of the items that are in this sort of orange color that you see on the slide, these are the things that we like to underscore and concentrate on when you take a closer look at our product, because it's not just about this particular solution. It's about our solution, how it fits into your greater security stack context, fitting in with other products you already have, making it easier to use for the staff, reducing the amount of fatigue that they have with current solutions. That's kind of the idea. That's our go-to-market strategy, and we would love to talk more with you all, and through Vandus, and we thank everybody for their time today. And if there are any questions, just please let us know. Are there any questions that came across at all?
I don't believe there's anything in the chat box. If anyone has any questions, you can feel free to type it in the chat box or ask it right now of our presenters. Or if you think of something later, you can feel free to send an email to either the presenters or the Vandus team, and we'll forward it along to them.
Well, certainly appreciate everybody's time today. And thanks, Lucas. You did a great job.
Thank you, everyone.
Great. Thank you, everyone, for attending. We hope you have a great day.